everyone at home. Hope everybody's staying healthy and doing well. This is our lesson for today. It is kind of a tricky one. We're going to talk about equations that have different kinds of answers. Okay, and we're really going to do this with just 3 equations. Okay, so first off, I'm going to look at 3 equations, and in class I gave everybody highlighters, so if you need a highlighter I can give this to you when you come back. I'm going to get my highlighter pen here. Grab it. Alright, so what we did in class is that we highlighted the coefficients separate from the constants. If you remember, the coefficients are the terms that have an x. Remember, x is the variable, the number in front is the coefficient. So 2 is our coefficient. So we're going to highlight the coefficient, and I'm going to highlight the x with it, the variable. And I'm going to do that on both sides. All right, so there's our coefficients. I'm going to do the same thing for our constants, but I'm going to put them in a different color. And I'm going to include the plus in front of it since it's a positive 5. Same with the 11. I'm going to include that plus. All right, and we're going to say what we notice about these 2 different problems, or I guess the coefficients and the constants. So what I noticed about the coefficients, 2x and 3x, is that they are different. They are not the same. We're just going to fill in same or different in these blanks. Look at the constants. The constants are also different. All right, so this is one type of question that we're going to talk about today. Equations that have both a different coefficient and a different constant. Okay, I'm going to skip this part down below, and we're going to go back to that here in just a second. But I'm going to do the same thing for 2 other questions. All right, so again, I'm going to get my highlighter. I'm going to highlight my coefficients one color. So again, coefficients are the numbers in front of the variables. And then I'm going to highlight my constants separately. So we've got a +5 and a +5. And I'm going to state what I notice. All right, so the coefficients, they were both 2x's. I noticed that they were the same. And the constants, the +5 and the +5, they were also the same. So this is another type of question or equation that we're going to talk about today, is when it's the exact same on both sides. Same coefficient, same constant on both sides. We're going to talk about kind of what happens in those types of problems. Again, we're going to fill this in here in just a second. I'm going to go down to the 3rd equation, do the same thing, get out my highlighter. Our coefficients here are 2x on both sides, and our constants are a +7 and a +10. Okay, so let's state what we notice about this equation. When we're talking about the coefficients, the 2x's, they had the same coefficient. The constants 7 and 10, they were different. And we're going to talk about what kind of solution we get on this here in just a second. So notice the 3 types of problems. Everything's different, everything's the same, or same but different. Okay, so all 3 of these equations are solved differently. You guys are used to ones like the first one, where everything's different. So let's start with that one. Now, in class, everybody was given a number to plug in and to see if they had the solution, and if they did, they kind of want a sticker in this problem. Okay, so obviously you guys can't do that. I'll kind of give you a heads up of how we know if something is a solution. So for example, if you had the number of 1 in the class, what they did is they took out the x's and they put parentheses instead. And they were trying to see if they plugged in their answer, which was 1, would the left side equal the right side? So would 2 times 1 plus 5, that'd be 7, equal 3 times 1 plus 11, that'd be 14. Well, 7 does not equal 14. So this person, if you had the answer of 1, would not have been a winner. And how do we know if it was a solution? We plugged it in. Okay. Now, if this was in class, we would have had just one person would have won the game. So we had one winner. I was teasing the rest of the class and called them all a bunch of losers, except for one. One was the winner. So that one person won 3 stickers. And that's what you guys are used to. You are used to equations that have exactly one solution. Okay, so again, these are the types of problems that you're used to where they have different coefficients and they have different constants. Okay, so let's quickly kind of solve this, how we learned on Friday how to solve this. So I'm going to write the equation. 2x plus 5 equals 3x plus 11. Just a reminder from Friday, we want the x's on the left side. So the one who's in the wrong spot is the 3x. And remember, if you switch the side, switch the sign. So that cancels out my x's on the right. I have negative 1x on my left. And now it's a 2-step. So I'm going to send that 5 to the other side by switching the side, switch the sign. So we have negative 1x equals 6. And last, we're going to divide by our coefficient to get us a final answer of negative 6. All right, it said, what did you notice about your solution and your answer from step 1? Well, we only had one answer and we had one person win the game. Okay, so that kind of makes sense. One solution is the answer. We had one exact solution, and that one solution was negative 6. Okay, so that again is when we have different coefficient and different constant. Those are the type of problems that you guys are used to. So I'm going to go back to kind of what we started at the very beginning. We said when they are different and different, we have one solution. And we're going to move on to equation 2 when we had everything the same. Okay, so let's look at that problem. I'll re-highlight just so you guys can see it again. So we had same coefficients and same constants. Okay, we started off the same way in class. We took out the x in the problem and put in a parenthesis. And everybody saw if their number was a solution. So again, we'll go back to our magic number of 1. Let's plug this into the problem. So 2 times 1 plus 5, that would be 7. And on this side, 2 times 1 plus 5 is 7. We had a true answer in this one. So ours was a winning solution. We would have won a sticker if you guys were in class with us. And the strange thing that happened is that everybody had a winning number on this problem, not just the one person. There wasn't one winner. In other words, no matter what number I plugged in, we were going to get a true statement. If I plugged in 3 on both sides, it would have worked. If I would have plugged in 10, it would have worked. Okay, so part B, how do I know if it was a solution? Again, we plug it in. And what would we have noticed if you guys were in class with us is that everyone is a winner. So everyone wins. Call this the Oprah problem, where it's you get a car, you get a car, everybody gets a car, so everybody's a winner. And that is whenever we have, like I said earlier, same everything, same on both sides. Okay, so my goal, I told the class, is that eventually you guys will be able to look at these problems and you will not actually have to solve them, but I want to show you kind of how to solve this and why we get the answer, the special answer that we got. Okay, so we always want the variables on the left, so x on the left. So this 2x on the right is on the wrong spot, so I'm going to subtract it on both sides. And so on the right side, it cancels out, which is what I want. But on the left side, notice it also cancels out. Don't put an x here, because if you put an x, that means there's one x. Our x's are gone. There's no more x's. 2 minus 2 is 0, gone. And I am left with 5 equals 5. So down below it says what happened to the variables or the x's in this problem? They canceled out. And when they cancel out, we have a special type of problem. We no longer have one answer. In this case, if you end up with a true statement in the end of 5 equaling 5, that's when we have our Oprah problem where everybody wins. In other words, every single number that you plug in for x is going to be true. So how many solutions does it have? Well, it doesn't have just 1 or 2 or even 10. Any number you think of would work. So it has infinitely many solutions. And if you are doing this on your homework or on a quiz and you want to shorten this, the best way to shorten this would be IMS, infinitely many solutions. So that could kind of give you a little break on all the writing. Now, if you notice on B, these equations also have infinitely many solutions. And there is a way to just look at these problems and know that they have infinitely many solutions. What do they all have in common? Well, they all have the same coefficient and they have the same constant. So same coefficient and same constant gives us an answer of infinitely many solutions. Okay, so I'm going to fill that back in on the first page that we started filling out. Different was one solution. Same was infinitely many solutions. All right, we're going to talk about one last problem when it's the same but different. Same coefficients but different constants. I promised my students that if they had a winner on this one, they won a whole package of stickers. So they got really excited. All right, so let's see what happens when it's a same but different problem. Okay, so equation 3 here. Notice, like I said, same coefficients, but different constants. Okay, so everybody in class plugged in their answer. And how did we know? They plugged it in to figure it out, and one side had to equal the other side. And what did we notice when it came down to who was the winner in this class? No one won. We had no winners. Everybody was a bunch of losers in this class. And so we started talking about why. Why did no one win? And it comes down to they both had 2x on either side. That was the same. So whether it was 2 times 1 or 2 times 5, on both sides it was exactly the same. But then they had a 7 and a 10 that was different. And so what they noticed in class is that when they plugged it in, all of the answers were 3 apart, because 7 and 10 are also 3 apart. Okay, so let's look at what this looks like when we actually do solve it. Again, the goal is that you won't have to solve these problems eventually, that you could just look at them and know the answer. So we want our variables on the left side. And so this 2x on the right side is in the wrong spot. So switch the side, switch the sign. That cancels them out on the right, and guess what? It canceled them out on the left again. So the answer to part A down below is that they cancel out. Kind of like the last one, they canceled out. But on the last one, I was left with 5 equals 5, which was a true statement. On this one, I'm left with 7 equals 10. That's definitely not true. That's a false statement. So when it's a false statement, it is still a special type of answer, but it's not the Oprah problem where everybody wins. This is a problem when it's the exact opposite. Nobody wins. No one is a winner. And so we say that our answer has, and so we kind of threw it around, and a lot of students were throwing out the answer of 0. But if I plugged in 0, that also didn't work. So 0 is not an answer. We say that this problem has no solution. And if you want a shortcut for writing this, we don't use NS. We use this symbol. It's like a O or a 0 and then a line through it. That is the symbol for no solution. You don't need the parentheses, just the O and the line through it would work. And so if you look at the right below it, these equations also have no solution. Again, the goal is that you guys can identify this without even solving the problems. So if you look at the problems, what do they have in common? Well, they have the same coefficients on both sides. So same coefficients. And if you look at the other part, they have different constants. All right, so final blank that I'm going to fill in here. I'll go back to the beginning. We had different was one solution. We had same was infinitely many solutions. And now we have same but different. That gave us no solution. Or that symbol. And those are the 3 types of equations that we talked about today. I'm going to give you a head start on your homework because I did for everybody in class. There are 6 questions total, and I'll do 3 of them with you. All right, so here is the first one. First off, you have to identify what kind of problem is this? Is this the different, everything's different, or everything's the same, or is this same but different? Well, if you identify your coefficients, I should probably use a highlighter here. Let me use my highlighter. All right, so if I highlight just to help me see, I see that I have everything's different. Okay, and if I go to my list that I started with at the very beginning, when everything was different, I knew that there was one solution. All right, so I have one solution. And then there's a part in your homework and it says, I know this because we have different coefficient and we have different constant. Now there is one tricky part when there's one solution. I can't just say there's one solution. I want to know what is the actual solution. Okay, so I'm going to subtract the 2x to move it to the left side. Remember, we always want our variables on the left. That gives me 3x plus 10 equal to 24. Now it's a 2-step, so I'm going to subtract 10 from 24. And I'm going to get, I'm going to skip over my writing, 3x equals 14. And my last step, divide by that coefficient of 3. That gives us x equals, and it's an ugly decimal, so I'm just going to leave it as 14 over 3. All right, so that was question 1. Let's do question 2. I'm going to get my highlighter out here. I'm going to highlight my coefficients, which are 5x. I'm going to highlight my constants, which are 10. I know that this is everything's the same, and same. And go back to my list of when everything was the same. That was infinitely many solutions. All right, so my answer is IMS. I know this because I have the same coefficient and I have the same constant. Okay, and I don't have to solve this one because if I know it's IMS, I already know the solution. I know that whatever number I can think of, if I would plug it in, it would work. There are an infinite amount of answers that would work. Hence, our solution is IMS. So I don't need to solve it. I'm going to do one last one. I'm going to break out my highlighter again. So highlight my coefficients, my negative 10x on both sides. I'm going to highlight my constants, 8 and 9. So this is that same but different. So if I look at my sheet that we did at the beginning, the same but different, we are going to get an answer of no solution. All right, so I know my answer here is no solution. Remember, you can use that symbol. And I know this because I have the same coefficient and I have different constants. And again, I don't have to solve this problem because I already know that no matter what I do, I'm never going to get an answer to this question. It has no answer. So our answer is actually no solution. There is no answer. All right, so the homework tonight is to finish the other 3 questions since we did the first 3 together. I will also post an answer key online so you guys can check your 3 problems after you finish. Hope you guys are doing great. See you later.